This is the LED circuit. A set of LEDs is connected to the 8051 port 1 through an inverting buffer. A logic 1 at the I/O pin is inverted to 0 by the inverting buffer. This causes the LED to be in forward bias and it lights up. This is the LED running program. This instruction copies the immediate data 1 to the accumulator. This instruction copies the content in the accumulator to port 1. This becomes the signal at port 1. This resulted in the first LED to turn on. The program delays for a moment. This is the rotate left accumulator instruction. The content in the accumulator is rotated to the left by 1 bit position. The short jump M2 instruction causes the program to jump to instruction at label M2. This instruction copies the content in the accumulator to port 1. The signal at port 1 changes. The second LED turns on. The program delays for a while and the second LED stays on. Content in the accumulator is rotated left again. Program jumps to M2. A is moved to port 1 again. Port 1 signal changes. The third LED turns on. Program delays for a moment. A is rotated left again. Program goes back to M2. A is output to port 1 and the next LED turns on. Program continues to run in the same manner and the LED runs from one position to another. Eventually, the content in the accumulator becomes 1000000. Another rotate left A instruction will cause the 1 to shift back to the extreme right. Outputting the content in A to port 1 causes the LED to go back to the top. The program continues to run in an endless loop.